Hello, welcome to another episode of Q&A about history of science and technology. And I see a whole bunch of questions here. You guys sometimes provide challenges to my knowledge and memory and so on. There's a question here from Jamie. Were there ancient travel bloggers, or the ancient equivalent, who wrote about places they visited? Well, weblogs, obviously, are a creature of the web, but people wrote all kinds of stuff. I mean, the things that have survived are presumably a small fraction of everything that existed. And there's just a lot of material that, in a sense, to us today is quite boring. I mean, I'm remembering there's a thing written by a famous Greek philosopher that's about dogs. And it's all about different kinds of hunting dogs and the personalities of dogs and so on. And apparently that's survived, but that's something which probably would have been lost in the mists of time. It's only kind of the things that, for whatever reason, kind of get picked out as being exciting. And unfortunately, things that would be exciting to us today were not sufficiently exciting in their time that they got copied. Because remember, the only way things survived was, well, sometimes it was even just an oral tradition, but even if it was written, it had to be progressively copied. And that was lots of work, so to speak. It wasn't until printed books started to exist in the 1400s that one had the possibility of having like a big print run where there were 1,000 copies of things that got distributed around the world. It was something where somebody in some monastery or some scribe or something had to explicitly make a copy. My impression is that there was quite a bit written about kind of what was out there in the world, and there were a lot of kind of very short descriptions written about kind of what one found in a particular part of the world, and a lot of kind of typecasting of, all people who live in X are like this type thing, and so on. But there were certainly I'm trying to remember whether there was a lot of description of kind of what happened in different parts of the world, what was there in different parts of the world. I mean, famously, Julius Caesar, starts off his Gallic Wars book by, Gaul is divided into 3 parts, and then he starts describing the tribes in each part and so on. So that was kind of in a sense, a travel account. He'd been there. Well, he'd at least, battled his way through there, so to speak. But so I think, that was a pretty common thing to describe what was out there in the world, as a matter of sort of history, travel, conquest. I don't know. I think that there were pieces of what was said where it wasn't clear whether that was sort of hearsay or whether that was a matter of, I went there and I saw it with my own eyes. I mean, famously, Troy, for example, which one knew about from the Iliad and so on, it wasn't clear that that was a real place in modern Turkey until it was excavated in the 1800s. And a thing that was described, I'm trying to remember where, maybe Cicero mentions it perhaps, the Atlantis. It's still not clear whether Atlantis that might have sunk into the ocean was a real place or not. My guess is it probably was a real place. Whether it was as dramatic as one would infer, I'm not sure, but that it was based somehow on reality, I would guess it was. I mean, famously, Cicero, in fact, also mentions somewhere something which is sort of a description of the Antikythera, mechanical computer device, which, again, sort of nobody really noticed that was said until after that device was kind of discovered and understood in the last few decades. And I wouldn't be surprised if there were other pieces of kind of writing from antiquity, which, if one happens to be lucky enough to be able to do the archaeology, one and discovers that there is a thing like that one will sort of read back and realize, yes, that was actually mentioned there. I think there are. I'm always certainly curious about the fact that one might think that whatever one knows about history is all one's ever going to know about history. But the remarkable thing is that more and more can be found from excavation or more detailed study or whatever else. I mean, there's the whole scrolls that were kind of buried uh, in the eruption of Vesuvius in 79 AD, which there's a big effort now to try and recover. And perhaps there'll be 10,000 scrolls from sort of ancient times there, which might have sort of a huge amount of information about what went on that's very different from what we have today. And I think as more kind of precise molecular scale archaeology is possible, it becomes conceivable to reconstruct more about the past than one ever thought one could. I mean, the fact that we can now take pieces of DNA just at a molecular scale and reconstruct things, know what type of wild boar was eaten at some particular, feast somewhere that got buried in some tomb or something. The fact that we can reconstruct things from the DNA is something we had no guess was possible before. And my own suspicion is that solid objects retain more memory than one thinks. That when one can actually sort of use atomic scale microscopy routinely, that one will discover that, oh, actually the usage patterns of this or that, one will be able to see that, and one will be able to deduce things. I mean, sort of one of the fun things to imagine is that there might have been something which at some point in ancient times would have been sort of a sound would somehow have been frozen somehow, where at a molecular scale one could reconstruct it and sort of replay what it actually sounded like in the Athenian agora or something like this. I don't know whether that will be the case, but I suspect there's more preserved in solid objects than one imagines. Anyway, a few thoughts on that. Let's see. The questions, gosh, the questions here about did ancient civilizations like Rome and Egypt actually communicate with each other? How did they know about each other? Yeah, they absolutely communicated. They would have, I mean, Rome and Egypt had many entanglements, from Mark Antony and Cleopatra to lots of others. I mean, obviously there were uh, the Egyptian civilization is much older than the Roman one. I mean, Rome was founded in 700 BC or something, and the Egyptians were doing things in 2500 BC and so on. So there wasn't there was a time when Egyptian civilization was flourishing, and there wasn't much happening in what's now Italy. So I think but when these civilizations did coexist, absolutely, it for at least the ones sort of around the Mediterranean and so on, there absolutely was contact, and there was extensive trade, and there were people, selling things and visiting and so on, and all that. I mean, a more interesting question is whether there was contact between, for example, well, a less obvious question perhaps is whether there was contact between Asian civilizations and European ones. And one knows there was contact to India, for example, but then in sort of but with Marco Polo and people like that, then that was a time, but that's in the Middle Ages and so on, where that contact happened between Europe and China. But I think there were times when kind of the kind of the Islamic Empire and the Chinese Empire sort of, I think, just came into contact once. I was just it's a fun thing to do with in Wolfram language. We have all of the historical country borders, and it's an interesting kind of experiment in kind of the space-time structure of country borders to see whether two great civilizations, did they touch in space-time, so to speak? Did they overlap in space but at different times, or how did that work? And I think those two just about came in contact at some point. But in the kind of Mediterranean area, yeah, I think everybody was in contact and much was communicated around. Formio asks, how influential was Babylonian science on Greek natural philosophy? My impression is that, well, there was I think it was pretty common in ancient Greek times to refer to the Chaldeans, which was kind of a term after a particular uh, um, dynasty of Babylon, I think. Um, but in any case, those were the astrologers and the astronomers. It's like the Chaldeans, the Babylonians, so to speak, and that was a thing people talked about in ancient Greek literature. But I think the question of sort of what what was learnt from there that was relevant to Greek philosophical thought. I mean, it's certainly said that Pythagoras had visited sort of the Babylonian part of the world, which was quite extended in those days, um, and that some of what he brought back as things like the Pythagorean theorem was certainly known to the Babylonians. It certainly wasn't invented by Pythagoras, but it's probably the case that Pythagoras learnt it from visiting and sort of hanging out in Babylonia, so to speak. And so things like that, things were sort of, in a sense, calculational mathematics. That was a thing that seems to have come from Babylon and seems to have been a very Babylonian kind of thing. When it comes to sort of the more conceptual, the sort of what is the nature of being and ideas like logic and so on, there is, I think, it doesn't seem to be the case that Babylon was a kind of hotbed of thinking of that kind. It seems like that was something that kind of conceptual philosophy was more of a Greek thing. Just like, by the time of Roman times, there was a lot more kind of emphasis on engineering and military prowess and things like this than there was on specifically on kind of the sort of conceptual philosophy that was popular in ancient Greece. So from what I know, that's the kind of the thinking about the nature of things as a kind of a conceptual direction. That seems to have been a pretty sort of Greek approach, remembering that in fact the Greek city-states extended over a quite large area. I mean, a lot of these people who we talk about came from random sort of islands they weren't all, sitting in Athens, so to speak. Far from it. It was quite a distributed kind of setup. And although people did come to Athens, they came to Alexandria, the Library of Alexandria in Egypt, and so on. That was where Euclid was, for instance. And so there was lots of mixing of that kind. Let's see. There's questions here. Oh boy, lots of ancient times questions. I'm doing my best on these. Okay, so Leo asks, how did people know how to tell time before clocks? Well, there were sundials, and in fact, a lot of time telling was based on things like local mean time, which was time as determined by where the sun was as measured by a sundial. So that was one type of time telling. The other sort of more local time telling were things like water clocks, where you would fill a big thing up with water, and over the course of some number of hours, the water would drain out to different levels. And I think in Greek and possibly even Egyptian times, there were sort of devices around the running out of the water that would sort of do things when the water ran down to a certain level. So that was sort of a local time telling. I mean, my impression is I might be wrong about this, but my impression is that it was not uncommon, particularly I think in Asian civilizations, to have, in the court for somebody to be walking through and sort of announcing the times every so often. I don't know when things like clocks chiming at the hour. I'm not sure. My guess is that came in when clockwork started to really be a thing. Now, there was sort of the analog of clockwork even in ancient times, and we know that from the Antikythera device. We know that from the devices of Hero of Alexandria, had devices that were sort of clockworky type devices. But I think that sort of clocks that, well, the next sort of big way to tell time at small time scales is pendulums, and sort of the swinging of a pendulum has this very important feature, which is a piece of math, basically, that if you have a pendulum swinging back and forth, the period of the pendulum does not depend much on how far the pendulum swings. So far as the swing isn't too large, it's just a feature of the math of elliptic integrals and so on, that the period is pretty much the same. As the swing of the pendulum gets too large, it starts to deviate from being a constant period. But so even as the pendulum kind of sort of runs down from friction, it's still going tick-tock, so to speak, at the same period. And that's a good way to kind of tell time. And when you combine that with clockwork, you are letting, every time the pendulum goes back and forth, it moves a ratchet, which turns a pointer around. And I don't think that was happening until kind of maybe the 1400s or so, maybe a little earlier than that. That was a systematic thing, that there were clocks like that. But it's not impossible, given what we know of the Antikythera device and so on, it's not impossible that that could have existed also in ancient times. But, the telling of time accurately is a comparatively modern phenomenon. I mean, the sort of the big issue, well, one issue was, can you tell time with by having something where you just have a pendulum go back and forth and you have to kind of wind up the grandfather clock or whatever to make sure the pendulum doesn't run down. You can tell time to some accuracy that way. As you start trying to get more accuracy, well, there are different things that come in. I mean, a big issue in the 1600s to 1700s was telling time at sea. That was important because while you can figure out the latitude that you're at by just looking at the altitude of the sun, to figure out the longitude that you're at, you need to, if you're going to do that from the stars or from the sun, you also need to be able to tell time. And so there was sort of a big challenge of, could you get some kind of clock that was maybe a pendulum clock or something to actually still work, even when it was being tossed around on an ocean in a ship? And that was finally people like Harrison and so on sort of solved that problem, and made marine chronometers that were fairly accurate, and allowed you to localize your longitude fairly well. But in subsequent time telling, I think the things that started to happen were things like in the 20th century were things like quartz oscillators, where you used the fact that there was, that you were, when I was a kid, for example, you could start to buy kind of electric watches that were using an oscillator, quartz oscillator, where there was digital electronics that would sort of be able to count up the number of vibrations of this little piece of little oscillator to be able to figure out how much time had passed. And then in the 1950s, there started to be atomic clocks, which were doing that, but not using a quartz oscillator, an actual sort of little tiny lump of quartz, but instead using the frequencies characteristic of particular atoms. Somehow cesium atoms seem to be a popular one to use. And looking at essentially the number of the precise frequency of photons emitted in atomic transitions, which are determined sort of only by the nature of cesium. Well, also a little bit by the gravitational field that it finds itself in because of the gravitational redshift effect. But to a very high accuracy, atomic clocks can certainly tell time as time passes at the surface of the Earth. You take an atomic clock into orbit and it'll sort of tell time slightly differently because of the gravitational redshift. But that was a thing from the 1950s. There started to be much more accurate time measurement technology. Nowadays, it's becoming sort of routine to have with this is a kind of a frontier of quantum metrology, is to be able to have extremely accurate time telling in very small devices. And that's certainly coming in the next few years. And when that does come, it will allow all sorts of things to be done, like much more accurate GPS type localization, things like this. So, and you know, the kinds of accuracy one's dealing with is, you know, things like 1 part in 10 to the 15, things like this, which means that you're kind of doing things like you're not losing a second in the whole history of the universe type thing. You're at that level of accuracy. But that's a thing of modern times. Let's see. Uh, Looking at Soph asks, did scientists back in the day have rivals or frenemies like we see in the movies? Oh, absolutely. Science is a human activity, and science, I think, has always had human drama, and it's also a place where there's sort of a lot of ego and competition that's commonly involved. And people were kind of going at each other's throats for, you know, who should get credit for this idea. It's always been rather undefined what credit means and what good credit does you, so to speak. And sort of what and how, you know, there isn't a framework. It's not like you file a patent and somebody gets to get the patent and somebody else doesn't get to get the patent. It's more, sometimes it's kind of like it was published in an academic journal, but that's sort of become rather meaningless in modern times. And back in the day, that wasn't really meaningful because there weren't really academic journals. There started to be professional societies by the late 1600s, things like the Royal Society in England started to exist, and then ones in France and Germany and so on. And they had proceedings which were, this is who came that week and sort of read this paper, and that and what was talked about was printed and distributed. But there was a lot of skullduggery in sort of in science throughout its known history. I would say that uh, the times when there sort of wasn't skullduggery is when people were building things that were really sort of new directions where there just wasn't anybody else there. And often it would be a lifetime or more than a lifetime to get people to care about that new direction. But there wasn't skullduggery because there was only one person who cared when the thing was being built. And I think I mean, there are many famous examples. For example, Isaac Newton and Gottfried Leibniz had lots of interaction about the invention of calculus. They had very different approaches to calculus. Leibniz was much more of a sort of symbolic approach to calculus. Newton was much more of a geometrical approach. Newton had these things called fluxions, the kind of dot notation that has survived for some purposes. Leibniz has the dy by dx notation, which Leibniz, even from the day he invented it, said people are going to be confused and try and cancel the d's. But in some sense, Leibniz's notation is in many ways a much more confusing notation, but it was the more popular notation, partly, I think, because calculus, sort of deeper uses of calculus took off more on the continent of Europe than they did in England, at least until sort of well towards the end of the 1800s, beginning of the 20th century. But between Newton and Leibniz, there was just a lot of kind of interaction where Newton, who had become sort of the president of the Royal Society, sort of convened a committee to investigate whether Newton or Leibniz, committee of the Royal Society, to investigate whether Newton or Leibniz was sort of the creator of the calculus. I don't remember the full details of this, but it was a very sort of put up job full of, you know, anonymous statements of this and that, where the anonymity was, you know, in the light of history, we know that it was, you know, Newton himself who was pulling the strings, so to speak. Leibniz had the bad fortune that he was sort of a a courtier to the Duke of Hanover, and he was supposed to write a history of the Dukes of Hanover, and he didn't get it done for like 30 years. And had he had it done, then by the time George III, who was a Hanoverian, came to be King of England, he would have been brought over with that court, and he would have been higher in the pecking order than Newton, and the history of sort of how one sees Leibniz and Newton might have been very different. But as it was, Newton kind of had the higher pecking order position and was able to pull lots of kinds of stunts. I mean, there was a thing, one of the Bernoullis had defined this problem, the brachistochrone problem, which is if you have kind of a bead running on a wire and you have to make the bead, it's kind of actually related to the pendulum problem. You have to make it so that the bead will oscillate up and down on the wire with the same period, independent of how big the excursion of the bead is. And there's the question of what shape will make that possible. And that problem was posed, I think, by one of the Bernoullis. And it was a thing where people were sort of anonymously sending in responses. And one of them was, in fact, written by Newton. And I think Bernoulli said something like, one can tell a lion by his paw, which is not clear whether that meant the method of solution was very Newton-like, or whether it was actually the handwriting was like, oh, I know old Isaac's handwriting type thing. You know, in terms of skullduggery, one of the other big instances of that around 1500 was the solution of the cubic equation. That was a story of Cardano and, Tartaglia. What's his actual name? I think that was the name he went by. And there was a whole sort of who could actually show the solution to a cubic equation. Now, you know, with all of its cube roots and complicated sort of arithmetic forms, I think that the thing that it was somewhat for show, because in fact, and it's even true today, that the number of times one needs that full complicated formula for the solution of the cubic is not very large. But it was a thing which back in those days in Italy, it was a thing where one would sort of demonstrate it to the public and at court that one could solve the cubic, and that was a very impressive thing. It was kind of like an analog. It was perhaps it would be nice if things like that happen in modern times, that you know, you can do some impressive mathematical feat, and that will kind of impress the public and the government, so to speak. That's not so true today. Maybe quietly one is mining Bitcoin or something, which is kind of solving a rather trivial mathematical problem, so to speak. But the idea of showing up at court and demonstrating that you can solve the cubic is not quite a thing of modern times. But that was a thing in 1500, and there was just remarkable skullduggery of people who said they stole somebody. There was somebody, maybe it was Cardano, had a young assistant, and maybe he'd stolen the thing from somebody else, and everybody sort of hated each other, and there was litigation actually about that, which I think has survived, about kind of, you know, who solved the cubic first. Not clear in the modern intellectual property scheme. It's more like a sort of who gets to advertise. You know, is it false advertising if you say I solved the cubic first, and it isn't true? But yes, the skullduggery has been a feature of the scientific and academic enterprise pretty much forever. It's not its best feature, I have to say. I must say that I think it is it's something where in modern times, last few decades, there's been sort of an attempt from time to time to kind of correctly add names to things which have been attributed to person A, and really people B and C had been also contributors. I've seen that happen a bunch of times. It's kind of a sad thing with things one invents oneself, that you know, sometimes things that are kind of trivial, you know, people proudly stick one's name on, and things which are much more interesting they forget. And then sort of there's this question of, you know, do you add extra letters and names to things? And that's been sort of a thing people have tried to do. I'm not sure how successfully, or whether it really makes sense, because some things, you can say, well, there were 20 people who contributed in some way to this thing, and what counts as the thing having really been discovered. And in the end, these names just become hooks for sort of cognitive hooks, just like words for things, and so it's not clear where the whole thing goes. Let's see. Gosh, you guys ask a lot of questions that I know pieces of the answer to. Um, Des asked, did ancient people have the equivalent of church bells to mark time in cities? I don't know. I don't know. I don't know whether the town crier went and uh, uh, the uh, and sort of went and they were giving announcements. It was kind of like the broadcast announcements from the town crier. But I don't think they went through and said, it's 11 o'clock, it's 12 o'clock type thing. Delia asks, were there ancient or medieval tech hacks that we'd still find useful today? Building cathedrals was a big, complicated issue. A lot of people tried to build cathedrals and it didn't work and they fell down. And I think finally the stonemasons, who were sort of the people who took responsibility for, okay, how are we going to cut these stones and then how are we going to pile them up so they'll make a cathedral and not fall down, were discovering all sorts of interesting geometry and so on to make that work. I'm not sure, that turned a little bit into the Freemasons, who became sort of a secret society and things like this. So I wouldn't doubt that there are at least rules of thumb about those kinds of sort of civil engineering problems that we don't have today. I think there are certainly some things with certain materials and things where we're still a little bit unclear how they get made. Various kinds of metals for making swords out of and so on. Now, there was a little bit of confusion there because some of the best metal you could find was very rare because it came from meteorites. And metal meteorites really are very metallic. You don't need a big sort of ore extraction sort of chemical process. You've just got metal right there. And if you heat it up and melt it down, melt it, and then you can fashion it into sword, and you have this remarkable kind of thing. But it's extremely rare because there just aren't that many meteorites. And so there are things like that. But there also are, I think, kind of processes where we don't quite know how they were made that way. I mean, sometimes there are, how were the violins made to sound so good? All those kinds of things. I mean, I tend to think a lot of those things are somebody became a very skilled craftsperson. They got a lot of intuition about how to build these things, and they sort of carefully did it. And people just haven't been as careful ever since, rather than that there was some sort of magic hack that was being used. But I'm not sure. John asks, why do I think the ancient Greeks had a fondness for abstract levels of thought? Is there an aspect of culture that enables this? I mean, the Greeks were certainly not alone in having kind of an interest in abstraction. I mean, certainly ancient Indian culture has that as well. I think Indian culture was not helped by the fact that it didn't have, things weren't getting written down. They were oral traditions. And there's probably a limit to how complicated the story can be in an oral tradition. I think that this question of when do you get to think versus when do you get to kind of be always fighting is certainly a question of kind of the ambient situation of the time. I mean, it's hard to know in retrospect. There were certainly periods of history, both in Greek times when people were fighting plenty, and where many of the famous philosophers from Socrates on had been warriors. It wasn't as if they were just sort of pondering philosophers all the time. They were people of action as well, at least at earlier times in their lives. And I think in sort of Roman times, there was plenty of sort of military might that was being wielded, but there were also periods when there wasn't that much of that going on, yet there wasn't as much, so far as we can tell, kind of abstract thinking. I think it is a feature of different cultures that they have different levels of, let's ponder this philosophically versus let's go just do it, and a predilection for concrete action. I mean, I kind of tend to think, I always thought of American culture, having grown up in England, a slightly different culture. American culture is a get things done and what matters is results kind of culture, whereas British culture, at least when I was growing up there, 45 years ago or more, was more of a sort of what's the proper thing, so to speak, rather than what are the results we're getting. So, these cultures are a bit different, and there are sort of questions of how seriously do you take intellectual activity. I mean, in England, when I was growing up, it was still the case that, scientists were viewed as the boffins who were quite impractical and wearing white coats and so on. And there are certainly parts of the world today where sort of science is viewed as impractical. There are places where it's like the scientists know everything and we should do everything they say. There are other places where it's the scientists have kind of blown it and we don't believe any of them, and so on. I think in, this question of what leads people to want to think deeply about things versus to just be, doing action kinds of things is interesting. I mean, I think if we look at modern sort of science in sort of Western countries and such like, in the US, for example, it has been the case that there's been an awful lot of just grind the machine, do more stuff, incremental progress, et cetera, et cetera, et cetera, and not a lot of let's think about the foundations and those types of things. I mean, I myself have been very interested in foundations of science and so on, and in a sense, foundations of technology. And I can say that it seems to be a pretty limited set of people who are really interested in those kinds of things. I'm actually not, I shouldn't say limited set who are interested. There's a limited number who are sort of trying to do it, if not for a living, at least as a very serious kind of use of time. And I think that's partly because the sort of system of kind of industrialized science, so to speak, doesn't really lend itself to, oh, let's go ponder the foundations. And I think that this question of sort of what leads to having the opportunity to do that, I mean, it's a certain amount of you don't have to fight to survive type thing that gives one the kind of the leisure to be able to sort of think deeply about things, rather than in the academic world, it would be sort of the publish or perish type dimension. And for example, for myself, the fact that I haven't been sort of a card-carrying academic in a long time has certainly made it easier for me to sort of think about foundational kinds of things. And I have to say, I suppose I was a successful enough academic that even when I was in that business, I still seem to have enough freedom to think about sort of foundational kinds of things. But that seems to be a not so common and perhaps getting rarer. Let's see. Well, maybe one more question and then I have to go to something here. Looking for something that might be an easy question. Well, Leo asked, how do people figure out that the Earth is round? That was known in ancient Greek times. I mean, Eratosthenes had estimates for the diameter of the Earth that were fairly accurate. And pretty much he did that by saying, you're at this place on the Earth and you're at that place on the Earth. And what's the difference in the angle of the sun between those two places? And in those days, there was good understanding of the geometry of, sun versus Earth and so on. The question of whether it was better to think of the sun going around the Earth or the Earth going around the sun, that wasn't really relevant to the question of sort of, there's the sun there, there's the Earth here, and how that worked. I mean, in the end, sort of even in kind of the equivalence between are you, in fact, sort of the this whole question of sort of, is it better to have a reference frame where the Earth is standing still and the sun is going around it, or where the sun is standing still, the Earth is going around it? That's a sort of detailed question. But that was for many centuries later, for Copernicus and so on. But at the time of Eratosthenes, which must be 150 BC, maybe, I might be wrong, sometime in the ancient Greek period, this thing about, the relative angle from two places that were separated by some distance at the same time. Now, how did they know it was at the same time? I'm not sure. I'm guessing that they sort of started in the middle, and it's like ride a horse to one side, ride a horse to the other side. If the riders are going for a certain amount of time, they're both going for a certain amount of time. I'm not sure how they knew what was how they established simultaneity. I mean, this was what sort of Einstein thought about a lot when he was waiting for trains, I suppose, in Zurich, and noticing all these wires that were connecting the train stations to try and synchronize clocks to have the trains run perfectly on time. This question of how do you synchronize clocks in two different places? And that was something Eratosthenes must have had to do to figure out what was the same time for these angles. But that was how that was originally figured out. And it was known reasonably accurately what the diameter of the Earth was when Columbus proposed to kind of go off and find a new way to the Orient, a new way to Asia, basically, across the ocean sea, as he called it. The fact was, if Eratosthenes' estimate of the size of the Earth was correct, and there wasn't any America, then the ocean sea was too wide to cross. Everybody would have been dead by the time they got to the other side. They just couldn't store food, and they would all have scurvy and all sorts of bad things. It was only, I think, because Columbus had some very hokey estimate of the size of the Earth that he thought he could get across the ocean sea quickly enough, in a matter of, I don't know, 6 weeks or something, to be able to not have everybody die before they reached the Orient. And I think it was sort of a lucky mistake that caused him to kind of go and decide to do the voyage because he had a wrong estimate for the size of the Earth. So I think that was you never know what the silver lining of kind of the of mistakes might be, but that's one of them. But as I say, in more detail, the diameter of the Earth was measured, well, in much more detail by the 1800s. Lots of things were known about things like the figure of the Earth, the precise shape of the Earth. It bulges out at the equator because it's spinning around. And then when Napoleon came to want to define a unit of distance, the meter, he did that by having this sort of line that goes through Paris and goes around the Earth. And what is it, 1,000,000 meters maybe around the Earth, 10 million meters around the Earth. And that was sort of his definition of the meter. And it was thought that the Earth, the size of the Earth was known pretty accurately by that time, so one could define a meter that way. That definition of a meter didn't survive, but it's now defined in terms of wavelengths of light and so on. But that was sort of the original thing, and that was, by that point, it was known pretty accurately. All right, I should go to my next thing here, but thanks for joining me, and thanks for lots of interesting questions, and I didn't get to a bunch today, and I'll try and get to them another time. All right, bye for now.